really small. All right, so that one, if you have this weirder indeterminate form, if you have the multiplication, the strategy is to rewrite it as division, and then it's going to work. Last one, and then we're done. Okay, let's see. So I got the limit as x is approaching 1, only from the right, because we don't want to have domain issues inside of the nat log. Let's see. If I were to plug in 1, remember ln of 1 is 0. So I'd have 1 over 0 minus 1 over 0. So initially, we do have the infinity minus infinity, which is indeterminate, but it's not L'Hopital rule eligible right away. You got to do something. And the strategy for here is going to be to just combine the fractions. Instead of having a fraction minus another fraction, which yielded the infinity minus the infinity, I really want to combine all this stuff, get it in one fraction, and in doing so, it's going to magically turn into one of those two nicer indeterminate forms. So let us go for it. Remember, I'm going to do my little fast adding trick to combine those fractions, and then we'll be able to get this answer. Okay. So fast add, I'm going to do cross multiply to get the top, and then I'm going to multiply across to get the bottom. So let's see, this times this, minus this times this, multiply across to get the top, multiply across to get the bottom. I'm going to just rewrite this. How about x minus 1 times ln of x. So I just used the fast adding trick to combine those fractions pretty quickly. Now let's see, if I were to try to now evaluate it, if I were to plug in 1 minus 1 would be 0. 0 minus, if you had ln of 1, that's 0. So if you were to plug in right now, you'd get 1 minus 1, that's 0, minus 0. So you would get a 0 on the top. And let's see about the bottom. 1 minus 1, so this chunk would be 0. ln of 1, that would also be 0. 0 times 0. How about that? Now I can see that when I've combined the fractions, instead of it being infinity minus infinity, now I'm going to end up having 0 over 0. So that's really nice. Combining the fractions enables me to now use L'Hopital's rule. Alrighty, let's go for it. Let's use L'Hopital's rule. Let's see, I think, yeah, I'm going to have a little bit of room. All right, so let's do the derivative of the top, then we'll do the derivative of the bottom. We're going to need product rule on the bottom. That's okay, we know how to do it. Let's go for the top first, though. The derivative first, the 1 goes away when you take the derivative. That's really nice. Then the derivative of your natural log is 1 over x. So there's your derivative on the top. For the bottom, you're going to need product rule. The derivative of the first is 1 times the second plus the derivative of the second times the first. Okay, so you had to do a little bit of work. Let's go through and let's just take this and distribute it. I'm going to try not to run out of room here, but I don't know. Let's see, yeah, I'm still on the screen. Okay, that's good. Kind of went off a little bit, sorry. Limit as x is approaching 1. Let's see, the top stays the same, so I have 1 minus 1 over x. Then I'm just going to simplify all the stuff in the denominator. I had ln of x, 1 over x times x. That's just going to be 1. Then 1 over x times this negative 1 minus 1 over x. Okay, awesome. That's good. Took the derivative. We applied L'Hopital's rule once. Let's see what we get right now. If I plug in 1 over 1 would be 1. 1 minus 1. Oh, darn it. I'm still going to get that 0 on the top. Let's check the bottom. ln of 1 is 0. So 0 plus 1 minus 1. So it's still 0 over 0. That's okay. Just keep using L'Hopital's rule until you get an answer. This one, I think we're only going to have to use it one more time, and then we'll be all right. All right. Oh, gosh. Sorry. Let's use L'Hopital's rule. Let's take one more set of derivatives, and then I think we'll be okay. Let's see. That one's going to go away when you take the derivative. Here, if you use your power rule, I think that one's going to end up being 1 over x squared. Remember, the negatives will cancel. Same thing here on the bottom, the derivative of natural log is 1 over x. The derivative of the 1 is going to be 0, and then the derivative of this is going to be plus 1 over x squared. Okay, if you need to, right, that's negative x to the negative first, right? Just looking at both of those two terms, you have x to the negative first. Then when you take the derivative, that negative is going to multiply to the front So you have a plus 1 x to the negative second power. So I kind of did that one pretty quickly, but it is just the power rule. And now, after I've used L'Hopital's rule the second time, now I think I'm going to be able to plug in and get an answer. Let's see, if I plug in 1 on the bottom, or if I plug in 1 for x anywheres, looks like you're going to get 1 on the top. You're going to get that this chunk is 1, that chunk is also 1. So we're going to end up getting 1/2. Did I keep it on the screen? Oh, look at that, I did. How wonderful. All right, so L'Hopital's rule seems kind of tricky. It seems a little bit complicated. It's really not. In fact, it's really nice. It kind of makes all those algebraic things, all those algebraic techniques and strategies that we had at the beginning of the year, it makes them all really obsolete. And you're like, Mr. Bell, why did we even bother learning them? Well, because you couldn't use L'Hopital's rule at the beginning of the year. To use L'Hopital's rule, you need to know what a derivative is, and we didn't know what a derivative was when we first started doing limits. So we had to kind of do it the longer way, algebraically, all those different techniques and strategies. Hopefully you kind of remember doing all those. But at the end of the day, they don't really matter. Like using the conjugate, factor and reducing. Hey, if it's a limit to infinity, let me find the big terms, ignore everything else. The limit's to 0, let me find the small terms and ignore everything else. Or those weird special trig limits or combining and simplifying fractions. All of those algebraic rules, they all get summed up and they all get covered with the one calculus rule called L'Hopital's rule. It's a very easy rule. Remember, if this original limit ends up being indeterminate, one of those nicer indeterminate forms, just take a derivative on the top, take a derivative on the bottom, and then you can work with that ratio of the derivatives. All right, hopefully that helps. Hopefully this video wasn't too terrible. I'm going to try to make another video here pretty soon about the inverses, so stay tuned.